Welcome to Cambridge IGCSE Physics, Lesson 16.1, Celsius and Kelvin scales. Today we explore temperature measurement using two fundamental scales in physics. The Celsius scale, named after Anders Celsius, uses degrees Celsius. The Kelvin scale, named after Lord Kelvin, uses Kelvin as the SI base unit for thermodynamic temperature. Understanding both scales and converting between them is essential for physics calculations. This lesson covers core content for your Cambridge IGCSE physics examination, focusing on practical temperature conversions and the relationship between these two important temperature scales. Let's examine our learning objectives for today. By the end of this lesson, you will achieve three key outcomes. First, you will convert temperatures between Kelvin and degrees Celsius using the standard conversion formula. Second, you will recall and use the equation T equals theta plus 273, where T represents temperature in Kelvin and theta represents temperature in degrees Celsius. Third, you will understand the Kelvin scale as an absolute temperature scale starting from absolute zero. These objectives align with Cambridge IGCSE assessment objectives: A01 for scientific knowledge, A02 for problem-solving calculations, and A03 for practical applications in experimental contexts. Now let's define our key vocabulary precisely. Each term is essential for understanding temperature scales. First, Kelvin, symbol K, is the SI base unit for thermodynamic temperature. It measures absolute temperature starting from absolute zero. Second, Celsius, symbol degrees C, is a temperature scale based on the properties of water, with 0 degrees C as the freezing point of water, and 100 degrees C as the boiling point. Third, absolute zero is the lowest possible temperature, equal to 0 Kelvin, or minus 273 degrees Celsius. Key symbols include T for temperature in Kelvin and theta for temperature in Celsius. Remember to use SI units consistently and follow proper scientific notation throughout your calculations. Let's explore our first core concept, the Kelvin scale. The fundamental principle states that Kelvin measures absolute temperature, starting from the lowest possible temperature in the universe. This means the Kelvin scale has a true 0 point, unlike Celsius, which uses arbitrary reference points. The definition is, the Kelvin scale starts at absolute zero, the theoretical point where all molecular motion stops. Mathematically, we express this as T equals theta plus 273. Where T represents temperature in Kelvin and theta represents temperature in degrees Celsius. The diagram illustrates the relationship between both scales. Notice how 0 Kelvin corresponds to minus 273 degrees Celsius, 273 Kelvin equals 0 degrees Celsius, and 373 Kelvin equals 100 degrees Celsius. This principle is fundamental because it provides an absolute reference for all temperature measurements in physics. Now we examine temperature measurement methods. This follows Cambridge IGCSE experimental standards. The apparatus needed includes digital thermometers for precise readings and liquid in glass thermometers for basic measurements. The method consists of these steps. First, calibrate the thermometer using known reference points like ice and boiling water. Second, immerse the thermometer bulb completely in the substance being measured. Third, wait for thermal equilibrium. This means the temperature reading becomes steady. Fourth, read the scale at eye level to avoid parallax error. Safety is paramount. The hazards include broken glass from thermometers and burns from extreme temperatures. Therefore, you must handle glass thermometers carefully and use appropriate protection near hot substances. The diagram shows a typical liquid in glass thermometer with scale markings and the correct reading technique. Let's work through our first example. The problem states, convert 25 degrees Celsius to Kelvin. We are given theta equals 25 degrees Celsius. We need to find T, the temperature in Kelvin. Step 1. Write the equation. We use the conversion formula, which is T equals theta plus 273, where T represents temperature in Kelvin and theta represents temperature in degrees Celsius. Step 2. Substitute the values. We write T equals 25 plus 273. Step 3. Calculate. 25 plus 273 equals 298. Step 4. State the answer. The result is T equals 298 Kelvin. We can check this makes sense. Room temperature in Kelvin should be around 300 Kelvin, so our answer of 298 Kelvin is reasonable. Example 2 applies the conversion in reverse. The problem is, convert 373 Kelvin to degrees Celsius. The data shows T equals 373 Kelvin. Now we analyse. First, rearrange the equation, starting with T equals theta plus 273. To find theta, we subtract 273 from both sides, giving theta equals T minus 273. Second, substitute values. We write theta equals 373 minus 273. Third, calculate. 373 minus 273 equals 100. Fourth, state the result. Theta equals 100 degrees Celsius. The physical meaning is significant. 373 Kelvin corresponds to 100 degrees Celsius, which is the boiling point of water at standard atmospheric pressure. The graph shows the linear relationship between Kelvin and Celsius scales, with our calculated point highlighted in red. Mathematical skills are crucial in temperature conversions. Let's examine 3 key skills. First, equation rearrangement. When we need to find a different variable, we rearrange algebraically, starting with T equals theta plus 273, where T is temperature in Kelvin and theta is temperature in degrees Celsius. To find theta, we subtract 273 from both sides. The result is theta equals T minus 273. Second, significant figures. When converting 25.0 degrees Celsius, which has 3 significant figures, our answer should also have 3 significant figures, giving 298 Kelvin. Third, unit analysis. Always include units in every step. K for Kelvin and degrees C for Celsius. Check that your dimensional analysis is consistent. Adding 273 to degrees Celsius gives Kelvin, which is dimensionally correct for temperature conversion. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, convert 0 degrees Celsius to Kelvin. This tests your understanding of the fundamental conversion at the freezing point of water. Question 2 is intermediate. It states, convert 300 Kelvin to degrees Celsius. This requires you to rearrange the equation and work backwards from Kelvin to Celsius. Question 3 is advanced. The question is, body temperature is 37 degrees Celsius. Express this in Kelvin and explain the significance. This tests both your calculation skills and understanding of temperature in biological contexts. For all questions, remember to show you're working clearly, include units in every step, and check that your answers make physical sense. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how temperature scales apply in practice. In space science, astronomers use Kelvin to measure stellar temperatures and cosmic background radiation because absolute temperature is essential for understanding energy emission and thermal processes in space. In medicine, body temperature monitoring uses both scales, Celsius for everyday clinical use and Kelvin for precise physiological research and international scientific communication. In engineering, thermal design requires absolute temperature calculations using Kelvin for heat transfer equations, thermal expansion calculations, and efficiency determinations in engines and refrigeration systems. These applications show why understanding both scales matters. Career-wise, physics knowledge leads to many professions. Meteorology uses both scales for weather prediction. Materials science requires precise temperature control during manufacturing, and aerospace engineering demands absolute temperature calculations for spacecraft thermal management. Let's review the solutions. For question 1, the answer is T equals 0 plus 273 equals 273 Kelvin. This represents the freezing point of water, a fundamental reference point. For question 2, we rearrange to get theta equals T minus 273, so theta equals 300 minus 273 equals 27 degrees Celsius. This is warm room temperature, which makes physical sense. For question 3, T equals 37 plus 273 equals 310 Kelvin. This represents normal human body temperature in absolute units. Now, exam success tips. First, always show you're working. Even if the final answer is wrong, you earn marks for correct method and equation use. Second, include units in every step, K for Kelvin and degrees C for Celsius. Third, check if your answer is reasonable. If you calculate a human body temperature of 3000 Kelvin, something is wrong. Fourth, memorize the conversion equation. T equals theta plus 273. This is fundamental for Cambridge IGCSE physics. Let's summarize today's lesson. The key points to remember are: first, the conversion formula T equals theta plus 273, where T is temperature in Kelvin and theta is temperature in degrees Celsius. Memorize this equation as it's fundamental for Cambridge IGCSE physics calculations. Second, the Kelvin scale measures absolute temperature, starting from absolute zero, the lowest possible temperature, where molecular motion theoretically stops. This makes Kelvin essential for scientific calculations involving thermal energy and gas laws. Third, both scales have important applications: Celsius for everyday temperature measurement and Kelvin for scientific and engineering calculations requiring absolute temperature values. For further study, practice additional conversion problems to build confidence and speed. Review the concept of absolute zero and its significance in physics. The next lesson covers thermal expansion, which builds on today's work by exploring how materials change size with temperature changes measured in both Celsius and Kelvin scales.